Okay, now before we get into number 2 here, I want to go through and review your quadrilaterals with you. Now you have what we call a quadrilateral organizer in your notes. So we are currently on page, I'm looking at my notes as we do this. We're currently on page 20, okay? Sorry, still not there. Did that not get printed? Oh, we're on page 19. But the page right before that, before this lesson 6 started, there is a graphic organizer of the quadrilateral family tree. So we need to first so that we can do the rest of these examples. So this next video will be filling out the quadrilateral organizer, which I'm going to go find now. So here's our family tree, and I'm going to run through this here with you, kind of jog your memories on some of the quadrilaterals and the properties. Now we're not going to fill out, not talk about complete everything about properties of quadrilaterals, but just enough so that we can start working through here and reviewing some of your prior knowledge. Okay, so we start off here at the very top with this dude, okay? This is just what we call a quadrilateral, 4 sides. Okay, and the one thing we can say about quadrilateral besides 4 sides is its interior angle sum. So what do those 4 angles add up to? We all remember that a triangle is 180 degrees. Then, well, if you're not sure what a quadrilateral is, what if I asked you about a square? What do those 4 angles add up to? Oh, 94 times. Quadrilaterals have an interior angle sum of 360 degrees, okay? Now, what if I say, okay, triangle's 180, quadrilateral's 360. What's a pentagon? Probably most people don't know. So down the road here in our next unit, we'll talk about degrees for other types of shapes, okay? But today is all about quadrilaterals. Okay, based off of the number of sides that are parallel, we can go one of 3 directions. So let's go over here to the right. Let's say we have 2 pairs of parallel sides, okay? If we have 2 pairs of parallel sides, we run into what we call then a parallelogram. Now, one way to tell if we have, say, marked that sides are parallel is by using these markings, these arrows. Those arrows, it's not a great arrow, okay? These arrows tell me that each pair of sides are parallel to one another, meaning they do not intersect. So that's what it means to be a parallelogram. Now, in a parallelogram, we have certain properties happening, a lot of properties actually happening. So let's go through some of the top ones here. Besides the sides being parallel, the opposite sides are congruent. So that side's congruent to that side. This side is congruent to this side. Okay, when all 4 sides are congruent, that's what we get down to just a few minutes, either a rhombus or then a square. So make sure you know the difference between the markings. Those tick marks mean congruent links, and if I had those arrows on here, that would mean, try this one more time. That would mean these mean parallel, okay? So from here, opposite angles, okay? So what I mean by opposite angles is, say, this angle with this angle. That angle with that angle, those angles are going to be congruent, okay? So when I did that little kind of angle marking, that was what we're going to continue to see throughout the year. And you should have seen those before. That means that the angles are congruent. Not all 4 of them are congruent, just the opposite ones are congruent to each other, okay? Now, what I mean by consecutives. Consecutive means right next to you, okay? Consecutive, like this one with this one, those are consecutives, okay? Consecutive angles, consecutive angles are what we call supplementary. Supplementary means adds up to 180 degrees. Again, that's that vocabulary coming in. And then opposite sides, we've already talked about. Opposite sides are congruent. And there's a whole bunch more we can talk about with the diagonals in there, but we're not there yet. From a parallelogram, we can go one of 2 ways. Now, if we go straight down to the right, we run into what we call a rhombus. It has all the properties that a parallelogram has, except now all sides are congruent. All sides are congruent. Opposite sides are parallel to one another. One other thing to throw in here about a rhombus that is helpful for us is that the diagonals, when they intersect, I can get a nice straight line there, did not make. The diagonals intersect at a right angle, okay? That's a random thing that pops up that is nice to know. But anyway, if we went down and to the left here, we ran into then what you're familiar with is a rectangle. All the properties of parallelogram, but now the adjacent sides are perpendicular. Now what do I mean by adjacent? Adjacent means right next to you. This is two adjacent sides. Perpendicular means they intersect at right angles. So adjacent sides are perpendicular to one another, meaning we get ourselves right angles, okay? Do my best to make a right angle. All angles are right angles, okay? And then we put a rectangle with a rhombus together, and then we get ourselves a square. And a square has all the properties of a rhombus, rectangle, parallelogram. So we've already talked about square. You guys know squares, but everything that flows down. Opposite sides are parallel. So technically I would also have like this arrow. An arrow means, again, that means parallel. Those sides are parallel to one another. I put a second pair of arrows on there. That means those sides are parallel. Everything continues to just kind of flow down. A couple other random things about a square. We've started talking about the diagonals of a square. And in this instance, from a square comes from a rhombus. The diagonals intersect at right angles. One thing I forgot to mention on a rectangle with the diagonals is, again, one of those random things that we've talked about in previous years. Now, have you, and did it stick? I don't know. That's a different question. The diagonals in a rectangle are congruent to one another, and they also cut each other in half. We call, in just a little bit of time, we call them, they bisect one another. So anyway, we'll talk more about that down the road, but those are random things about a rectangle, rhombus, and square. Okay, that was with two parallel sides, a parallelogram. What if we came straight down and we had just one pair of sides? We run into then what we call a trapezoid. One pair of parallel sides, boom, boom. Those sides are parallel. The other two are not, okay? They are not parallel. And with a trapezoid, it's 360 degrees. There's a couple other random things that we'll talk about down the road. The one thing that we can say with the trapezoid, well, I'm not going to get into it, but this angle is supplementary to that angle, but we'll talk about that, I think, in the next unit. Now, the one trapezoid we usually talk about more specifically is this dude right here. Opposite sides are parallel, okay? And then the non-opposite sides, which is this one and this one, they are congruent. And what we call this is, and think about what we've done before where legs are congruent. This is an isosceles trapezoid, okay? So what I just marked are legs. Legs are congruent. And then something about base angles. So this is called base, say 1. This is called, say, base 2. These are my two legs that are congruent. These are base angles. Base angles, and then these two up here, I gave them double markings because that means those are congruent. The base angles are congruent. So this one to this one's congruent. And together, I said them a few minutes ago, these are what we call supplementary, okay? Again, we'll talk more about that down the road when we get into the next unit as well. And lastly, what if we had no pairs of parallel sides, okay? This is where we run into is called a kite, okay? No pairs of parallel sides. The best thing that we can say is 2 pairs of adjacent sides are congruent. So that's what we mean by 2 pairs of adjacent sides are congruent. And no opposite sides are congruent. So that opposite sides means, hey, these are not congruent right here, okay? The only other thing kind of fancy about a kite is here in the diagonals. It's nice to know that the diagonals in a kite are also perpendicular, okay? So one of those random things, again, when you went through quadrilaterals back in prior years, if you didn't, well, I threw that out there right now, that we'll randomly use that throughout the year, okay? All right, that's the graphic organizer.